This question says, consider the reaction below. The reaction begins with only reactants and the concentration of C2H2 is initially 0.25 molar and the concentration of Br2 is initially 0.3 molar. At equilibrium, the concentration of C2H2Br4 is 0.062 molar. What is the Kc value for this reaction? All right, so this is basically acetylene, and we're adding bromine to it, and we get 4 bromines attached to basically an ethane group. So this is what we're looking at here. And in this case, we're going to use what's called an ice table. And an ice table has initial, change, and equilibrium concentrations of each thing. So the initial concentration of C2H2 is provided in the question. It is 0.250. The initial concentration of Br2 is 0.300. And the initial concentration of C2H2Br4 is 0 because the reaction begins with only reactants. So there's only reactants present and there's no products present. I should note that all of these concentrations are in molar, so I'm going to put the molar up here instead of trying to write it every single time. Now let's look at the change in concentration. Well, at equilibrium, the concentration of this one is 0.062 molar. So we must have gained 0.062 molar of this, so that at equilibrium it's 0.062 molar. For the C2H2, we must have lost this, because for every one of these that we make, we use one of these. Note that because the reaction volume does not change, we can actually subtract molarities here. It's the same as subtracting moles because the volume is constant. So we're going to subtract 0.062 molar of this one because, I said I wasn't going to write them and then I did, because we made that much of this one. When we do that math, we find that at equilibrium, this one is 0.188 molar. The Br2 is a little bit more challenging because in the case of the Br2, it takes 2 of these to make one of these. So if we have 0.062 of these, we must have lost twice as many of these. Said another way, we need to subtract 2 times 0.062. Why 2 times? Because 2 of these make one of these. So we have to lose twice as many of these for every one of these we made. And when you do that math, you find that this one is 0.176 molar. We now have all of the equilibrium concentrations. This makes this exactly like the previous question. Maybe 2 questions ago was exactly like this, but the previous question was similar. So we need to write the Kc expression. So the Kc is products over reactants. Concentration of C2H2Br4, concentration of C2H2, concentration of Br2 squared. Okay, because there's 2 of them. We now have all of the equilibrium concentrations, so we can plug in 0.062 for the concentration of the product divided by 0.188 times 0.176 squared. And when you do that math and you round to 2 sig figs, you get the Kc value that is equal to 11. So this is the first time that we've used the ice table, and you're going to use these a lot in the next 3 chapters. So it's really important to get familiar with the ice table.